Hi and Assalamualaikum. My name is Nur Aziza Atira binti Abdul Aziz and my matric number is DE220131. Today we are going to present about our group project for signal and system. We are required to work with MATLAB, and this project is related to the Fourier series. The Fourier series is a mathematical tool to analyze and represent periodic functions by breaking them down into a sum of sinusoidal functions. It is named after Joseph Fourier and widely used in signal processing and various fields. The series expresses a periodic function as a sum of cosine and sine terms with different frequencies. The coefficients determine the amplitudes of these terms by considering more terms, and more accurate representation of the original functions is achieved. This mathematical tool is vital for analyzing signal in fields like audio processing and image analysis. And this is why we are using MATLAB to make our project related to the Fourier series to make it more easier.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nuisman bin Asmawi. My matric numbers is DE220116. Today I'm going to explain about coding for the Fourier series. Okay, so for the part of the given parameters, here we have defined some fundamental parameters. The fundamental frequency F0 is 180 kHz and the carrier frequency Fc is 1100 kHz. The period T0 of the fundamental frequency is calculated as its inverse. Okay, and for the define the numbers of harmonic, we have specified a list of numbers of harmonic to consider in the Fourier series. This will be used to demonstrate how the signal changes with increasing harmonic. And for the time vector, this creates a time vector t spanning one period of the fundamental frequency with 1000 points. And for the time domain signal visualizations, we initializing a figure counter and creating a new figure window for plotting time domain signal. And for this loop from here until here, we compute and plot the time domain signal for different numbers of harmonic. The Fourier series representations is approximate by summing up the sinusoidal component for each harmonic. And for this part frequency domain analysis, we're creating a frequency vector spanning from negative 1100 kHz to 1100 kHz with 5000 points for frequency domain analysis. And here compute frequency spectrum for the signal with 220 harmonic. Here we compute the frequency spectrum of the signal using the first 20 harmonic. This sinc functions is used to model the frequency component of each harmonic. And here plot the frequency spectrum figure. Finally, we plot the frequency spectrum of the signal obtained using 20 harmonic. The magnitude of the spectrum is plotted against frequency, and the x-axis is limited for the better visualizations. In summary, this MATLAB script demonstrates how the Fourier series can be used to represent a periodic signal in terms of its constituent sinusoidal component in both time and frequency domain. And this is for the result of the MATLAB coding for the Fourier series. So the first one is time domain signal for 5 harmonics. Second one is time domain signal for 10 harmonics, and the last one is time domain signal for 20 harmonics. And for this one, this is the frequency domain analysis for the 20 harmonics for the Fourier series. That's all for me. Thank you.
Assalamualaikum and greeting for everyone. My name is Muhammad Khairul Asfar, DE220193. Now we will demonstrate the low pass filter simulation by MATLAB. And now I will show the coding. But it's first, let me explain the coding itself. So, CLC and close all is the clear the command window and close all open figure, and I also define the FO and FC that given by the lecturer, which is the FO is 180,000 kilohertz, and which is the sampling frequency is 110,000 frequency for FC, and for the calculation normalized cut-off frequency, I will use the W is for normalized cut-off frequency for calculate FO divide by F2 per FC by FC by 2. Now I will design the Butterworth low pass filter, which is filter underscore order, which is filter order 5, and to calculate the frequency response, which is H and W, which is this frequency response, which is using frequency function, FREQZ function, and we convert the angular frequency to hertz, which is update the W to represent frequency in hertz instead angular frequency. So this is the angular frequency hertz, which is W same with a W divide with substitute with FC divide by 2 substitute with pi. So now we start to plot the frequency response in log scale with using a figure function, and we plot which is W for the x-axis, and Y is 20 log ABS-H for K symbol. So ABS, which is the function of ABS, the return of the absolute value with each element H. So with the grid on, and I also put the title of that plot for our easier understanding, and I also label the X value, X label which is frequency, and Y label is gain, and another plot which is filter frequency response without log scale, which also same. But for the second plot, which is I don't use the 20 log, just absolute H and W, which also the type X label is frequency and gain. Now we start the simulation. So now we get two graph, which is the first graph is a filter frequency response without the log scale, and another one is filter frequency response with log scale. So we can see for filter frequency scale, let me so the gain start to degrade from 1.6 kilohertz until 5, which is before 1.6 kilohertz they are 0. For the figure 2, we can see when filter frequency response without log scale. Let me okay. start point 1.1 kilohertz. The gain from the one degrade until the zero at the 4 kilohertz. Thank you very much and Assalamualaikum.
So next I will proceed to the discussion for the result MATLAB. So the MATLAB simulation proved that the predicted behavior of the low pass filter by putting the signal into it, efficiently attenuating higher frequencies beyond the prescribed cut-off frequency while maintaining the lower frequency component. Any observed variation or inconsistency between the stimulated output and the theoretical expectation supplied the vital information about the real-world element. Fourier series analysis allowed the signal to be broken down into their harmonic component, showing the detailed frequency content and the time domain representation for 5, 10, and 20 harmonic. After passing the signal through this filter, the output was cleaner in both temporal and frequency domain. When these MATLAB generated findings were compared to theoretical prediction and realistic simulation, the correctness of the developed filter was proven, indicating its capacity to modify signal as planned. The investigation of different duty cycles demonstrated how variation in temporal aspect affect the signal behavior, providing useful insight into signal processing approaches.
Assalamualaikum. My name is Irina Nunalira binti Roshamzani, matrix number DE220141. I will conclude the project. So in conclusion, the Fourier series analysis is a powerful technique in signal processing. A periodic signal can be represented as a sum of sinusoidal functions. The outcome of Fourier series analysis can be concluded based on the accuracy with harmonic expansion. The number of harmonics included in Fourier series expansions increases, so the signal becomes more accurate in approximating the original signal. As the harmonics increase, the waveform converts to the original signal. Meanwhile, in frequency domain, each harmonic in the Fourier series contributes a peak in the spectrum. The filtering impact of the time and frequency domains allows a comprehensive understanding of how a signal is modified by a low-pass filter. Changes observed in the time domain, which represent the influence of the filter on various frequency components, are reflected in changes seen in the time domain, such as the smoothing or rounding off of the edges. Overall, the main point is to engage students in a comprehensive exploration of signal analysis and filter design, and culminating in a practical demonstration. That's all. Thank you.